Welcome to lesson 7-6, inverse trigonometric relation graphs. So the objective of this lesson is about plotting graphs of inverse trigonometric functions and relations and find exact values of functions of inverse trigonometric functions. So we begin this lesson by graphing our principal trigonometric functions. Okay, so let's graph first the tangent functions in or the inverse tangent function. So let us select values of x and y. Okay. Well, actually, when you think about inverse trigonometric functions, these are the graphs of the inverse functions of sine, cosine, and tangent. So for example, we have y is equal to tangent of x. The inverse of this would be x is equal to tangent y. So in the previous episodes of this course, in the previous lessons, we have graph tangent function as occurring or having an asymptote every 180 degrees or every 90 degrees instead, and it has a graph which seems to look like this. Okay, now we're going to get the inverse of our tangent or inverse tangent, so to speak. Then we're going to get a reflection which is on the y-axis. Okay, so meaning we're flipping this, we're going to flip this into across the horizontal axis. So in other words, the y value here will be the independent variable, and the x values here are the dependent variables. So maybe we could try to put here the value of y, okay, and this would be the value of the x, which is the inverse tangent, or the inverse of the tangent function. So x is equal to tangent y. And let's get the result by getting values of y from, let's say, from negative pi over 2 up to pi over 2. So that extends from negative pi over 2 going to negative pi over, let's say, 4. And then we have negative pi over okay, let's get from negative pi over 4, and then we have 0, pi over 4, and pi over 2. So if our x is, or if our y rather, is negative pi over 2, that means that we have radian here. So pi divided by 2 equals, this is negative. Okay, and get the tangent of this. So tangent, it's undefined. So we have an asymptote at this portion. So it does not exist, meaning we have an asymptote here, we also have an asymptote here. So negative pi over 4, that would be pi divided by 4. Okay, negative tangent, that would be negative 1. So this is negative 1, this is positive 1. And at 0, then our x, this would be 0. Okay, so to sketch that, this is our x-axis, this is our y-axis, and let's label our the thing that we found here. We have negative 1. So let's put it like this. And here. And we have 1, 2, negative 1, negative 2. This is the x-axis, of course. This is the y-axis. This is 1. This is negative 1. And this is, let's say this is pi over 2. This is negative pi over 2. So we have horizontal asymptotes instead of vertical asymptotes here. And the horizontal asymptotes occur at negative pi over 2. So one stays here. And the other one at pi over 2. So one is 0. Now when x is 0, y is 0. That means that we have allocation of a point at the origin, and when pi is or when y is equal to pi over 4, which is somewhere here, because it's in between pi over 2 and 0, and here we have 1 and negative 1. So this would be 1, and this is negative 1. Okay, so after that we can now actually trace the curves. So this would be like this. Okay, so this is our inverse tangent. This is what we call x is equal to tangent y, or y is equal to the inverse tangent of x. Okay, so this is the inverse tangent of x, or y is equal to inverse tangent of x. Okay, so this equation is the inverse tangent of x. Now the same is true for cosine and for sine. And let's have this notion about graphs and principal branches. So we are successful in conveying the graph of the inverse tangent of x. Now, how do we get the principal branch of a certain given inverse trigonometric relation? So there are rules in finding the principal branches of the given trigonometric relation. So the criteria for selecting principal branches for inverse trigo functions are: number 1, it must be a function, so meaning it shouldn't double. Okay, so what I'm trying to say is, if you have this function, now this is the inverse sine function. I don't know if you can reduce it looks a little bit shadowy. Let's enlarge it. Okay, this is the inverse tangent function. Okay, now to get the principal branch, first it must be a function. So meaning when it says it should be a function, then we have to consider only one portion of the graph. Because if we are going to get all of the graphs here, that wouldn't make it a function already. Okay, because we have, if we use the vertical line test, then using the vertical line test would cross this function, or this graph of the tangent function, of the inverse tangent function, at several points. So we only have to select one point, or one representative of the graph. So this is where we select it. Okay, so we select only this portion of the graph. Okay, next, it must be the entire, or it must use the entire domain of the inverse trigonometric relation. So when you say entire domain, it must use the entire domain. So what is the entire domain of this trigonometric function? It's from negative infinity to positive infinity. So it uses the entire domain of the trigonometric relation. Okay, what else? Let's see, for sine function. For sine function, this is the deal. Okay, if we're going to select this as the principal branch, then the domain of this function, of the inverse sine function, is actually from this point, which occurs at 1 to -1, or from -1 to 1. That is the domain of our inverse sine function. So it uses the entire domain of the function. Okay, next, it should be one continuous graph, if possible. It should be one continuous graph. Now this is continuous. This graph is continuous. It doesn't have any break. It doesn't take into account the asymptotes. Okay, these are the asymptotes. So this is one continuous graph. And at the same time, look at these graphs here. This also is continuous. It is continuous from -1 to 1. And it uses the whole of its domain from -1 to 1. This is also continuous. It doesn't have a break here, because this is the secant, the inverse secant function. So it is continuous from here going there. Okay, it is continuous from this point going there. So all of these functions are continuous at the given principal branches. Okay, number 4, it should be centrally located near the origin. So looking at the red portions, just take a note that the highlighted portions of each graph shows the inverse trigo function. Okay, so look at these highlighted portions. They are very near the origin. So these are the representatives of the function, the relation. Okay, the relation, to select the principal branch of this relation, you have to look for the value, or those portions of the graph which are very near the origins. In this case, this is very near to origin. At the same time, this is near to origin. Okay, so look at this. These are near to the origin. This is near to the origin, and it's on the positive side, so we chose it. Okay, next, if there is a choice between two possible branches, use the positive one. So that's what we are talking about. So look, that we have a choice here to either use the positive or the negative. So we chose the positive part. Also here, we chose the positive part. Well, we don't have a choice really here. So we have near the origin, but in here we have a choice. we either select the negative and the positive, but we have to select the positive counterpart. Okay? Also in here, we have to select the positive counterpart. Okay? So these are how to choose the principal branches. So by the way, this is the graph of the inverse sine function. So the sine function oscillates into the x-axis, but in here it oscillates into the y-axis or around the y-axis, and so on and so forth. So what are the ranges and domains of inverse trigonometric functions? For the inverse sine function, our domain lies in quadrants 1 and 4, so from -1 to 1. Look at the sine function. Our sine function has a domain which occurs from x element of the interval -1 to 1, as you can see here. It's from -1 going to 1. And the range here, this is the domain. The range is actually from -infinity to +infinity. But if you're going to look for the function, this is about the trigonometric function, and we've selected the principal branch. So the range here would be y is an element of, this is the function we're considering. So we have from -π/2 to π/2. Okay? Now let's take a look at the tangent function. So the inverse tangent function has a domain which is an element of real numbers. In other words, it's from -infinity to +infinity. Okay? But the range here, it stays from -π/2 to π/2. So the range is an element of -π/2 to π/2. Note that at y is equal to -π/2, there is an asymptote. So this is the range of our tangent function. What is the domain of the secant function? So the secant function has a domain which is from -infinity going to -1, okay, union 1 to +infinity. And the range here of this secant function, range is occurring from 0 to pi. Okay, so this is from 0 to pi. Okay, for the cosine function, for the inverse cosine function rather, our domain is from -1 to 1 also, similar to the sine and the inverse sine function. And the range is from 0 going to pi. Okay, so y is an element of 0 to pi. Okay? For the cotangent function, our domain is in between 0 and pi, or I mean it's actually element of r, or from -infinity to +infinity, And the range is from 0 to pi. Okay, now for the cosecant function. The cosecant function has a domain which is similar to, it's actually similar or the same as the domain of our inverse secant function. So the domain here is equal to negative infinity going to 1, and united or union, it's negative 1. In union, 1 to positive infinity. And the range here is from negative pi to going to negative pi over 2. I'm sorry. So from negative pi over 2 going to pi over 2. Okay, negative pi over 2 and then it has an asymptote at 0, union zero pi over 2. Okay, so this is the range of the cosecant function. Now in summary, these are the domains and ranges of our inverse trigonometric functions. So for y is equal to inverse of sine, the y is an element of the interval pi over 2 to negative pi over 2 to pi over 2. And it lies in quadrants 1 and 4, and the domain is x is an element of negative 1 to 1. For the inverse cosine, the domain would be from, or the range would be from 0 to pi, inclusive of 0 and pi, and lying in quadrants 1 and 2, and same domain as sine. For the inverse tangent, this is from negative pi over 2 to pi over 2. This is the range. And it lies in quadrants 1 and 4. And the domain is all real numbers. And for inverse cotangent, the range is y element of 0 to pi, exclusive of 0 and pi. It lies in quadrants 1 and 2. And the domain is element of real numbers. For y is equal to inverse secant, the range is from 0 to pi, and y cannot be equal to pi over 2. Okay? And for cosecant, it would be y element of pi over 2 or negative pi over 2 to pi over 2, and y cannot be equal to 0. It's exclusive of 0. Okay, so these are the ranges, and the domains would be for inverse secant, it should be greater than or equal to 1 absolute value of x. So meaning x should be greater than or equal to positive 1, or x is less than or equal to negative 1. The same is true with the inverse cosecant function. Okay? So let's go for examples.